Welcome to my Cultivate Software channel, which is all about smart software engineering practices that will help you build better software faster. My name is David, and in today's episode I want to discuss a test anti-pattern. Many developers hate having to write tests. Besides literally not knowing how to do it, the reason is often a test suite full of anti-patterns, a test suite that is not fun to work with. Here's one of the dozens of anti-patterns that I identified over the years. Adding more than 3 expectations to a test case. Let me give you an example. Let's assume we inherited a project and we are now facing this code. We have an isValidPassword function that is based on this ugly regex, and we have 2 tests. Here's the test protocol, so isValidPassword returns true when password is valid and returns false when password is invalid. The problem with these tests is that having more than 3 expectations in one test is a strong indicator that multiple test cases are mixed together. These tests often carry implicit knowledge, and maintaining these tests will be difficult and expensive. So let's assume something goes wrong with the isValidPassword function. Let's assume someone introduces a bug related to handling numbers. So now we can see that one of the tests is failing. The second one returns false when password is invalid. That's good. But it's not obvious why, and that's a problem. Now we have to waste precious time on debugging the issue. And that's one reason why software engineering is so expensive. So let's change that. Let's refactor these lousy tests into good ones. So let me revert this bug back. Okay, now the test should be green again. When we look at these tests, the first thing we notice is that there are more than 3 expects per test. That's a smell. There seems to be multiple test cases mixed together in this test. Another thing I noticed is some of these passwords have obviously been generated and pasted into this test file. Why is that a problem? Well, it's not clear what the verifications are exactly about. Look, they even have comments. If we feel the need to comment and explain the code, we should consider improving the code instead. In this case, the test code. All test cases deserve their own test with a proper name, and distinct test cases will make it also easier to find a bug. So let's get started. Let's start with this one. Let's give this expectation the test case it deserves. I'm going to cut it out here, and I'm going to write a new test. And this test here, I will name it rejects password without number. Okay, so here's the callback that will hold our expectations. I paste it in here, and now we don't need this comment anymore. All right, let's save that. Yep, this test is passing. Okay, next, here, no special character. Let's cut that out. Let's turn that into a test case that says rejects password without special characters. Okay, here we go. Let's paste that, let's save that. Test is green, we don't need this comment. All right. So now what about the remaining expectations? Like this one here, for instance. What is this about? We can only guess, but it looks a bit like it's about passwords maybe not having uppercase letters. So let's create a test case for that. I missed that one here. It rejects password without uppercase letters. All right, let's paste that one here. Think the test is passing. Yep. The only problem is now that this password is invalid due to multiple reasons, actually. It also has no special characters and it has no number. So let's make sure that this expectation actually fits to the test case, which is about uppercase letters. So let's put in a special character and let's put in a number. Now it's only failing because there are no uppercase letters. All right. The next expectation is again, well, it's a mix of different issues. No special character, no number. We have tested that already, so I think, yeah, it's best to get rid of this redundant expectation. All right, what's next? Maybe what comes to my mind is If we test for uppercase letters, then maybe we should also test for lowercase letters. Rejects password without lowercase letters. Okay, so maybe let's turn all these letters into uppercase letters, and then there's no lowercase letter left. Save that. Yeah, that passes. This was actually not tested so far, so we have now a test case that was missing. Okay, now let's look at the last expectation here. It seems to be about passwords that are too short. Yeah. Let's have a look at the code. Yeah, here the regex says it needs to be at least 8 characters long. All right, then let's rewrite maybe this test here and call it rejects password with less than 8 characters. And yeah, but again, I mean, this test is passing, but again, this password fails because it is too short, but also it fails because it has no number, no special character. So let's put in a special character, let's put in a number, and maybe let's also put in an uppercase letter so that it has everything, but the only problem is it's too short. Okay, yeah, and it's still passing. That means this test is really now testing this aspect about the problem. Less than 8 characters. Okay, let's have a look at the valid passwords. Well, I can only guess, but I think all these passwords are valid, and I would say maybe at least 2 of these 4 expectations are just redundant. They don't add any value, so let's get rid of them. Okay, what else can we do? Maybe we can look at the test protocol, and we see here this looks different. So let's make sure that it looks maybe a bit more symmetric. This test could say accepts password when valid, maybe just when valid. Let's save that. Yeah, this looks much better. And how about replacing these random passwords actually with something that is making it a bit more clear that the password itself doesn't matter. Like my go-to password when it comes to testing is usually password. And if you want to have 2 variations, then the other one I like is secrets. So let's save that. Yep, test is still passing. Here, same thing. It's not really clear why this password qualifies. But if we take maybe the one password that we are using most test cases here, let's put that in here. And if we now make it invalid and remove the number that is actually expected, then it's much easier to see the issue. Same here, let's put in a valid password and let's replace the special character with this letter, which is actually the A. So I think up here we probably have maybe an A too much here as well. Let's remove that. Okay, all tests are passing. Now when you look through the tests, you will encounter only one password besides this one here. But usually it's really clear, like what's the difference? Like here it doesn't have a number, this one doesn't have a special character. This here is the same password but without uppercase letters, and this is the same password again but without lowercase letters. Makes it really easy to understand the test. Nice, I think we're done. Okay, let's compare our refactor test code with the lousy version from a few minutes ago. In the new version, the cognitive noise is now significantly reduced. Thanks to simple dummy passwords, it's now much easier to grasp what's going on. It takes less energy to understand what the difference between the test cases is, because we only alter what's essential. And we don't mix multiple test cases into one test or even into one expectation, like here. And if tests are easier to read and understand, it also means the codebase will be cheaper to maintain going forward. Also, look at the test protocol. Now it does an excellent job at documenting what the tested code does. These are all the requirements, and all these requirements deserve a test. There's no need for additional commands. The tests document the code. If you had to explain the algorithm for the isValidPassword function to someone else over the phone, this is what you would say in one way or another. IsValidPassword accepts password when valid, rejects password with less than 8 characters, without number, without special characters, without uppercase letters, without lowercase letters. Let's again assume that something goes wrong. Let's say someone introduces a bug. So let's simulate that. Now, what we see here is that the test rejects password without number is the one that's actually failing. So we immediately know what the problem is. With a lousy test suite, it was unclear what the issue was. With our improved test suite, we can clearly see what the problem is. And that will save us time and energy and allow us to focus on shipping more features instead. Okay, let's wrap it up. Here's again the test anti-pattern that brought us here today. Adding more than 3 expectations to a test case is bad. More than 3 expectations in a test is a strong indicator that multiple test cases are mixed together in one test. All test cases deserve their own test with a proper name. Tests that mix multiple test cases in one test, like in the bad example here, often carry implicit knowledge and will be difficult and expensive to maintain. Notice also how the lousy code example relies on comments to explain itself. Cleaner code can eliminate the need for comments in most cases. In the improved code, the tests take a double role. They verify the correctness of the code and they also document the code. Distinct test cases will also make it easier to find bugs when something goes wrong. By the way, if you're working with Jest, there's also a linting rule that can remind you and your team to identify, refactor, and avoid tests with more than 3 expectations. That's it for today. Please hit the like button if you liked this episode and subscribe to my channel if you want to catch the next one. And if you're interested in learning more about how to write better tests, check out my Test First programming course at udemy.com. I've added a link for you in the description of this video. Bye!